Okay, so what you just observed in the bell work is you notice that when you multiply the two factors, the middle terms canceled out, and it's because of the sign difference, right? So anytime you have two factors that have the same numbers, and they have different signs, the middle term cancel out, and we call this a conjugate. So a conjugate is where we have the middle term, so we change the sign in the middle is the simplest way to think of it. So if I have something like A plus B imaginary, and if I wanted the conjugate, that would be the same number and the same imaginary number, but just the middle of the sign is flipped. So the first equation here is the conjugate of the second equation. And then A minus B I is a conjugate of the top. So here's an example. So if I have something like 6 minus 8i, well then the conjugate is just the same numbers, but now there's a plus sign. Pretty easy, right? So this, or these two expressions are conjugates of each other. Okay, so we talked about conjugates in the previous slide, and now what we're going to do is actually utilize them. And how we use it when we're working with imaginary numbers is through division. And so in this case here, you can see that these two, top and bottom, are actually being divided, right? It looks like a fraction, but fractions is basically division. I'm taking this top number here, or this top imaginary number, and dividing it by this number down here, which is actually a complex number. But anyhow, we're dividing. So in this case here, if I want to divide, I actually have to multiply this bottom here, the denominator, by its conjugate. So what I'm trying to do is get rid of the imaginary number here. So to do that, I have to multiply by the conjugate. And I'll explain why here in a minute. But first, I'm going to multiply the bottom by its conjugate. Let me redo that. Getting ahead of myself. So the bottom conjugate is going to be 3 minus 5i, because that part was a positive and now it's going to be a minus. So what we do next is if I multiply the bottom by the conjugate, that means I also have to multiply the top by the same conjugate. So whenever we are dividing, we multiply the bottom by its conjugate. And if we do it to the bottom, we have to do it to the top, because when we look at this overall, right, if the top and the bottom are the same, doesn't this equal 1? Let's take a moment to talk about that. Whenever we have two numbers that are the same on top of each other, whether it's a fraction, whether we're dividing, right? So 5 over 5, what does that equal? 1. 100 divided by 100, or 100 over 100, what does that equal? 1. Well, in this case, when we look at these two, they're the same, and if they're on top of each other, or if you're dividing them, this is going to equal 1. Well, 1 times this is still going to be itself. So we really don't do anything to this equation when we're multiplying it by the conjugate. And so in this case here, that's why we are multiplying it top and bottom by the same conjugate. So let's keep going. So when we're multiplying this out, we need to distribute. Let's do the top first. So we are multiplying negative 2i. Let me write that in black. Negative 2i times 3 minus 5i all over 3 plus 5i, 3 minus 5i. So I need to multiply this out, and I'm going to do the top first. When I multiply this negative 2i into each term, let's see what we get. So for the top, negative 2i times 3, that's going to give me negative 6i. Negative 2i times negative 5i is going to be positive 10i squared. And that's going to be all over, let's see what the bottom's going to be. The bottom here, I actually have to FOIL out. Now, if you notice that the middle terms cancel out right at the get-go, then you can go ahead and just write it out where the middle terms cancel. Now, I'm going to do it fully out just because we're still practicing. So I'm going to work it all out and FOIL. So in this case here, 3 times 3 gives me 9. 3 times negative 5i is 15i. And then 5i times 3 is going to give me positive 15i. And then 5i times negative 5i is going to be negative 25i squared. And so, like we said before, you can see here that the middle term of the bottom, the denominator cancels out, right? And so let's see what we have left. So the top here, I have negative 6i, 10, but this I squared, remember, I squared is just negative 1. So in place of I squared, I'm just going to write a negative 1. And then the bottom here I just have left is this 9 and this negative 25i squared. So that's going to give me 9 minus 25, while I squared is just negative 1. And so I'm going to keep working this out. Top can be reduced down to negative 6i. There's a negative in front of that 10, so if I multiply, I get negative 10. 9 minus 25, so negative 25 times negative 1 is going to give me a positive 25. So that's actually 9 plus 25. And did you notice that also when you multiply by conjugates, that the imaginary number gets squared, right? So the i's get canceled. The I squared becomes a negative 1. And notice, does the bottom have any more i's? No. If we add the bottom, we get 34. And then the top is 6i minus 10. And so what we're doing when we're multiplying the bottom by its conjugate is actually we're deleting or we're removing the imaginary number from the bottom. So we're no longer dividing by an imaginary number. We get down to a real number. The top is still imaginary, and that's okay, but the bottom isn't. So that's what we're doing when we're multiplying by a conjugate. So I'm going to pause there.